Product variability is built on the premise that a product can be offered in multiple configurations or versions to more closely satisfy our customers' demands. Managing more versions of a product while reducing costs requires organization and planning. In the variant modeler approach to configuration, that organization is the 150% structure, typically the engineering BOM. We will begin by reviewing the engineering BOM of our product. We see it as a structure on the left and a visualization on the right. The EBSD is composed of a case, a motherboard, power supply, RAM, many card options, and metadata objects like instruction manuals and firmware versions. As I walk down the structure, selecting components, the corresponding item is highlighted in the visualization. Please notice that many of the components appear on top of each other. The 150% BOM, or super BOM, is an overbuilt condition. This means that when we go to configure a new variant, we will simply be filtering out the excess or uncalled components. Let's configure a new version of our product. The configuration interface shows the available options arranged in groups. The first group is sales features, including market, language, and manufacturing site. These features can also include constraint-based rules, such that when I select the market as Japan, the language is automatically set to Japanese. But when I select the US market, Japanese language is excluded, and San Jose is automatically selected for the manufacturing site. In a similar way, the hardware features are presented for the processor, RAM, fan, and number of power supplies. Selecting the best processor forces inclusion of the largest RAM and the cooling fan. The better processor selection allows for choosing a RAM size and if the fan is included. The standard available rule types are inclusion, exclusion, default, and availability rules. Rules can have single or multiple dependencies, such as and/or conditions. Formula-based rules and freeform rules are also available. As I continue making selections, filling the bays for this new variant, those selections are kept as a list on the right column. I also see that it's a valid but not yet complete selection set. I'll continue making selections until I'm finished. At that point, we see that we have a valid configuration and it's complete. When I press apply, we see that the bill of materials is filtered. We can go look at the visualization and see that our new configuration is complete. And the BOM structure has been filtered down to a 100% version that I now want to save. This could be a product code or a tail number, or in this case, as a SKU number 5. There's also a description available as a quick identifier. Or we could also search existing variants by feature selections, such as which variants from San Jose use a particular processor. After saving, we see that the list of existing variants now includes SKU number 5. Loading SKU number 4 refilters the structure, and I see that this is a Japanese market version made in Osaka. Let's switch again to SKU number 2. This filtering is available across my other data management functions in Team Center, such as ECOs and comparing BOMs. I will split the screen, and by loading 2 variants, I can easily compare SKU number 2 with SKU number 4. So the planning and organization occurs in the 150% BOM. The filtering occurs in configuring variants, and those variants can be called across Team Center. The compare tool shows in red that the RAM and language selections are different between the 2 configurations, and that the bay arrangements are in a different order. In summary, we have seen how to manage a product family from a single 150% structure. We went through the process to create a new variant, save it, retrieve other variants, and compare them quickly and easily. The goal is to efficiently make our products in versions that more closely meet our customers' needs.